So imagine finding out that the universe isn't some, empty void of random magical probabilities, but is actually structured like a giant 39-layer block of vibrating digital pixels.
Right, which sounds completely crazy at first.
It really does. But today we are doing a deep dive into a theoretical framework that claims the quantum world isn't magic at all. It's literally just a fluid dynamics problem that we just haven't been able to see.
Exactly. I mean, you've probably heard the standard refrains about quantum physics. It's weird, it's spooky, a particle is everywhere and nowhere until you look at it.
Right, Schrodinger's cat and all that.
Yeah.
We're basically told that the fundamental nature of reality is just a roll of the dice, and we just have to, I guess, accept it.
And that expectation of fundamental weirdness is something physicists have been wrestling with for a century now. We like things to be tangible. We want clear cause and effect.
Yeah, human brains don't like randomness.
Yep. Exactly. But the standard model basically tells us that at the smallest scales, reality just blurs into abstract math. However, the stack of theoretical physics documents we are diving into today presents an absolute paradigm shift.
And we really mean a paradigm shift.
It's called the SDMT framework. That stands for Substrat Dynamique Multitor. And it basically takes the most mystical, counterintuitive parts of quantum mechanics and argues that they are entirely deterministic.
So that is the mission for this deep dive. We're going to unpack how this SDMT framework attempts to rewrite our understanding of reality from the ground up.
It's a huge undertaking.
It is. It claims that the famous Schrödinger equation-like, the very math usually used to prove the universe is just a cloud of probabilities, is actually the native deterministic law of a physical fractal fluid.
And to even begin grasping how this works, we have to completely reset our baseline understanding of empty space.
Right, because standard physics pictures a vacuum, a literal void where fields just occasionally vibrate or particles pop into existence out of nowhere.
Yeah, but the SDMT framework tosses the void entirely out the window. In this model, space isn't empty. Space is the plenum.
The plenum. Okay, let's define that because it's the absolute foundation of everything we're about to discuss today.
Right.
The sources describe it as a discrete physical medium made of superfluid, thixotropic hydrogen. That's a lot of big words.
It is, yeah. Let's break down those properties, starting with superfluid. In classical physics, fluids have friction.
Like stirring a cup of coffee.
Exactly. You stir it, and it eventually stops swirling because the kinetic energy is lost to heat. But a superfluid, like liquid helium at near absolute zero, has zero friction.
So no energy is lost at all.
None. It possesses a single quantum ground state that extends over its entire volume. If you stir a superfluid, that vortex will literally spin forever.
Okay, so the universe is filled with this frictionless fluid that allows waves of energy to travel across billions of light years without dying out. That makes sense. But the second word is thixotropic.
And the thixotropy is the defining characteristic of this entire framework. A thixotropic fluid is stress responsive.
What does that mean in plain English?
It means it can solidify or basically jam up under high shear stress. It resists further compression, and then it fluidizes again when the stress is released.
Like ketchup.
Yes, the classic example.
It sits in the bottle like a solid blob, but when you smack the bottom of the bottle, when you apply stress, basically, it suddenly flows like a liquid.
Or quicksand, which operates on a very similar principle. In the SDMT model, the fundamental hydrogen substrate of the universe possesses both of these properties, superfluidity and thixotropy, at the exact same time.
Wait, how can it be both frictionless and sticky?
Because it's context-dependent. Because it's a superfluid, it can support stable, quantized vortices that spin forever. We actually perceive those spinning vortices as physical matter.
Wow, okay.
But because it is thixotropic, it can also resist collapse and lock into rigid geometric structures when it's put under pressure or stress.
Okay, hold on. I need to push back here a little bit. We are about to jump into a theory that claims the entire universe is made of a stress-responsive hydrogen fluid.
I know how it sounds.
Right, because a lot of theoretical physics can sound like mathematical pareidolia, like we're just playing with equations, finding patterns and numbers, and pretending they reflect physical reality. How does this framework actually ground itself?
It's a fair question.
Because standard physics relies on what, like 19 or 20 free parameters? to make its equations work?
19 free parameters in the standard model, yes.
Yeah.
You've got the mass of the electron, the fine structure constant, the cosmological constant, the coupling strengths of various forces.
All these arbitrary numbers.
Right. These are numbers that physicists simply have to measure in the laboratory and then literally plug into their equations by hand to make the math work out.
So it's basically like a cheat code.
Sort of, yeah. The standard model equations cannot explain why the electron weighs what it does. They just accept that it does.
But the staggeringly ambitious promise of the SDMT framework, and this blew my mind when reading the sources, is that it requires 0 free parameters.
0. None at all.
I really want the listener to grasp that. Everything we are going to explore today, from the mass of particles to the actual flow of time, is derived strictly from a single integer, the number 39, and 3 locked geometric constants.
And those 3 constants are not just arbitrarily chosen to make things fit. They are geometric inevitabilities of the fluid's physical structure.
What are they, specifically?
The first is the scale propeller, which is denoted by the Greek letter beta. And beta is exactly the square root of 137.
Okay, square root of 137. Got it.
The second is the temporal friction, called gamma. That one is the square root of 5 over 13, which comes out to roughly 0.172.
And the third one?
The third is the equilibrium shear angle, phi sub c, which is exactly 55.17 degrees.
So, just to be entirely clear for everyone listening, you're saying every single particle mass, every fundamental force comes from the number 39 in an angle.
Yes. The framework argues that these constants emerge totally naturally from the discrete tiling of the universe's topology.
Let's break those down a bit more. What does the scale propeller actually do?
Beta governs the fractal scaling. It dictates exactly how the fluid's geometry shrinks or expands across different scales of reality.
Okay, and the temporal friction, gamma.
Gamma is the topological drag. It's the friction that actually gives us the arrow of time. Without gamma, the universe would just be a frozen static crystal.
Wow, and that angle, 55.17 degrees?
That shear angle is the thixotropic rest angle. It's the precise physical angle at which the fluid minimizes its own internal stress. And here's a crazy detail. If you double 55.17, you get 110.34 degrees.
Which is, wait, isn't that something to do with water?
Exactly. That happens to be the exact bond angle of a liquid water molecule.
Oh, wow. Okay, let's unpack this. If this thixotropic superfluid hydrogen is the raw material of reality, what is the structure? I mean, we can't just have an infinite ocean of ketchup. There has to be a geometry to it.
There is. The sources describe the physical stage of the universe as a discrete lattice. They call it the golden cross.
The golden cross.
Yes, and it is constructed from exactly 39 to the power of 3 interconnected nodes.
So 39 cubed nodes.
Right, and this lattice features a Klein bottle topology with helical boundary conditions.
Okay, let's visualize a Klein bottle for everyone. People might be familiar with a Mobius strip, right?
Yeah, a piece of paper twisted once and taped together.
Right, so it only has one continuous side. If you trace a line on it, you cover both what was the top and the bottom without ever lifting your pen. A Klein bottle is basically the three-dimensional version of that.
Exactly.
It's a shape that loops back into itself. It has no inside and no outside. It is a completely closed, non-orientable loop.
If you were a spaceship traveling in a perfectly straight line along the curvature of a Klein bottle universe, you wouldn't eventually hit a brick wall at the edge of space.
Because there is no edge.
Right. You would eventually end up exactly where you started, but your spatial orientation would be flipped, like a mirror image. The crucial aspect of a Klein bottle here is that it is a manifold that contains itself.
Meaning what, exactly?
It means it doesn't need to sit inside a larger external space. It doesn't require an outside void to exist within. It is its own absolute container.
Okay, that is super weird to think about, but I'm with you. And the dynamics inside this self-contained container are governed by something the sources call a Laplacian.
Yes, specifically 3 discrete Laplacians.
Right. They mention the neutral Laplacian, the Julia Laplacian, and the Mandelbrot Laplacian. Let's ground this before we go any further. What actually is a Laplacian in plain English?
In classical calculus, a Laplacian is a mathematical operator. It basically measures how much the value of something at a specific point differs from the average value of the space surrounding it.
Okay, give me a visual for that.
Think of a tightly stretched trampoline.
Okay.
If you place a heavy bowling ball right in the middle, the fabric obviously dips down. The Laplacian measures the curvature, the tension of that dip, relative to the flat fabric around it. It is essentially a mathematical measure of localized stress or tension.
But classical calculus assumes that the trampoline fabric is perfectly smooth and continuous down to infinity, right?
And that's exactly where the SDMT model diverges from standard physics. Because the Golden Cross lattice is discrete.
Right, it's pixelated.
Exactly. It is made of distinct, countable nodes rather than a smooth continuum. So we cannot use continuous calculus. We have to use a discrete fractal Laplacian.
And that's the L39 operator they talk about.
Right. You can think of the L39 operator as the master stiffness matrix of the entire universe. It mathematically dictates exactly how topological pressure moves from one discrete node to the very next node.
Wait, pressure from what? If there's no actual physical bowling ball pressing down, what is topological pressure?
It's the geometric stress of the lattice trying to maintain its own shape. Remember the thixotropic nature of the fluid. It responds to stress.
Right, the catch-up.
Yes. So the three Laplacians represent the three structural phases this fluid can exist in. The L39 neutral represents perfect equilibrium. That's the fluid at rest.
Unbothered.
Exactly. Then the L39 Julia governs the expansion phase of the lattice, and the L39 Mandelbrot governs the contraction phase.
So reality is literally a grid, like a 3D pixelated video game, but made of superfluid hydrogen that's constantly expanding and contracting.
That analogy gets us part of the way there. But we really need to be careful with the word grid. It isn't a rigid, static structure like a sheet of graph paper.
Okay, how should we picture it then?
It's a dynamic self-computing network.
Yeah.
The pixels aren't tiny, empty boxes of space. They are interconnected strata of pressure. And this is where the number 39 really comes into play.
Because it's 39 cubed.
It's not just the width of the grid. It's the maximal fractal index. The universe literally has 39 distinct layers of reality nested inside each other.
Oh, I see. So it's scaling from the macroscopic size of the entire cosmos all the way down to the subatomic, shrinking by that beta factor, the square root of 137 at each step down.
Think of a fractal sponge. It looks like a solid block from a distance, but as you zoom in, you see holes.
And you zoom into the walls of those.
Because you see smaller holes. Exactly. The SDMT universe is a sponge that exists across 39 different scales simultaneously. The L39 stiffness matrix mathematically encodes how the fluid at one scale influences its neighbors at the next scale, using those exact geometric weights we talk about.
Using gamma and the shear angle.
Yes. The forward path of the pressure uses the friction constant, gamma, and the lateral projection paths use the cosine of that 55.17-degree shear angle. The dynamics of literally everything in physics reduce down to the diagonalization of this single geometric matrix.
Okay, so the piano is built. We have this 39-layer thixotropic Klein bottle sponge. It has tension. It has a stiffness matrix.
Right.
But a piano sitting in an empty room doesn't just make music on its own. If this grid is just the physical stage, how do the actors, like the particles, know how to behave?
That is the big question.
Right, because if there are no free parameters and no arbitrary physical laws being handed down from on high, where does the actual behavior of a proton or an electron come from?
And this is where the SDMT framework takes its most audacious swing at standard physics. It targets the most famous equation in all of quantum mechanics, the Schrödinger equation.
Okay, I think everyone has at least heard of the Schrödinger equation. But in the standard model, it's basically treated as a given, right?
It is. It's a fundamental postulate. Erwin Schrödinger derived it, and it works brilliantly to describe how the wave function of a quantum system evolves over time.
But nobody really knows why it works?
Exactly. Physicists can't necessarily tell you why the universe obeys this specific equation. It's just the rule book we happen to find.
It's the math that says a particle isn't a tiny billiard ball, but a wave of probabilities.
But in the SDMT framework, the time-independent Schrödinger equation isn't some abstract rule hovering over the universe. It is intrinsically contained within the geometry of the plenum itself.
Wait, contained how?
It is quite literally just the equation for the stationary resting states of that L39 neutral stiffness matrix we just talked about.
Oh, wow.
Mathematically, it's expressed as L39 neutral applied to psi equals lambda times CII.
So you're saying the discrete Laplacian operator, the physical tension of the fluid, is the Hamiltonian?
Yes, and let's clarify what a Hamiltonian is for a moment, just so everyone is on the same page.
Good idea.
In standard quantum mechanics, the Hamiltonian is the mathematical operator that represents the total energy of the system.
That's the kinetic energy of the moving parts plus the potential energy stored in the fields, right?
Yep. Exactly. You apply the Hamiltonian to a wave function to figure out the allowed energy states of a particle. But in the SDMT, the Hamiltonian isn't some abstract concept of total energy. The discrete Laplacian L39 on the Golden Cross lattice is the Hamiltonian of the plenum, period.
It's just the literal physical tension of the fluid distributed across the 39 cubed nodes.
Exactly.
This is where things start clicking together in a really profound way. If the Hamiltonian is just the physical tension of the lattice, what does that make the eigenvalues? Because in standard math, solving the Schrödinger equation gives you eigenvalues, which physicists interpret as the specific, allowed energy levels a particle can have.
In the SDMT, those eigenvalues, those lambdas in the equation, directly yield the masses of all fundamental particles.
Wait, all of them?
All of them. The electron, the proton, the W and Z bosons, the Higgs boson.
That's incredible. So they aren't random numbers we just happen to observe in a particle accelerator.
No, they are the literal resonant frequencies of this specific 39-layer lattice.
Let's expand on that piano analogy because I think it perfectly illustrates this. The L39 neutral Laplacian is the physical piano itself.
Right. The wood, the iron frame, the exact tension of the strings.
And when you strike a key on a piano, you get a very specific acoustic note. An A sharp, a C natural. You cannot play a note between the keys.
Exactly. The piano is structurally, geometrically constrained to only produce those specific frequencies based entirely on its physical tension.
And in this framework, those unchangeable musical notes are the particles in the CERN standard model table.
That's exactly right. The mass of the electron isn't a free parameter that could have been anything else if the universe was slightly different. It is simply the lowest possible resonant frequency of the hydrogen lattice at its specific fractal scale.
The sources mention a master scaling law to back this up, right? They claim that the mass of any particle is anchored to the mass of the electron and then scaled mathematically by that beta factor.
Yes, by the square root of 137, based on its specific fractal stratum, which they call its K-index.
So that explains the hierarchy of masses, like the fact that something like the top quark is so massively heavier than the electron, which has always puzzled physicists.
Yes, it's explained as a simple exponential scaling on the Golden Cross lattice. The electron exists at a specific layer, stratum K equals 18.
Okay.
The top quark exists at a much higher magnitude.
Yeah.
They are the exact same geometric distortion, the exact same shape of topological pressure in the fluid, just played on a higher, more energetic octave of the 39-layer piano.
Okay, so the piano keys are there. The masses are literally set by the geometry. But a piano playing a single continuous chord forever is basically a frozen universe.
Right, nothing would ever change.
If this grid is just vibrating with stationary eigenvalues,
Right.
how does anything actually happen? What is the player that strikes the keys and forces this fluid to move through time? How does the SDMT explain the time-dependent Schrödinger equation?
This brings us to another massive conceptual shift. In standard relativity, time is treated as a continuous fourth dimension, a smooth, flowing river.
Space-time.
But in the SDMT framework, time does not flow. Time ticks.
It ticks like a
Yeah.
clock.
The entire plenum evolves in discrete, quantized time steps, driven by what the authors call the jitterbug oscillation.
The jitterbug. I have to say, it sounds like a 1920s dance, not a fundamental mechanism of astrophysics.
It's an appropriate name, honestly, because it is a rhythmic dance. The jitterbug is a 1 Hertz geometric flip.
1 hertz, so once per second.
Exactly, once per second at the macroscopic scale. The geometry of the lattice continuously flips the thixotropic friction, gamma, from positive to negative and back again.
So it's alternating the friction.
Yes, it mechanically drives the fluid from the Mandelbrot contraction phase into the Julia expansion phase, back and forth endlessly.
Wait, stop. 1 hertz, 1 tick per second. If the fundamental frame rate of reality is ticking at 1 frame per second, why does everything look so incredibly smooth and continuous to us?
I see what you're asking.
I mean, if you look at a high-speed camera capturing a bullet shattering a pane of glass, it doesn't look like it's stuttering forward once a second. It's fluid.
This is where that fractal depth is absolutely crucial to keep in mind. The 1 Hertz is the macroscopic heartbeat. It's the global synchronization pulse of the entire Klein bottle universe.
Ah.
But remember the scale propeller, beta. The true microscopic time step, the tick occurring at the smallest scales of the lattice where particles actually operate, is scaled down by a factor of beta to the power of -18.
Beta to the -18. That is a very small number.
Extremely small. This scaling makes the local quantum level temporal resolution incredibly tiny. In fact, it mathematically aligns perfectly with what standard physics calls the Planck time.
Oh, wow. So the Planck time, which is something unfathomably small, like 10 to the negative 44 seconds, is just that 1 Hertz heartbeat scaled down 18 layers into the microscopic realm.
Precisely. At each microscopic tick, the state of the fluid is updated by a discrete unitary rotation.
Like a computational cycle in a processor.
Very much so. The state of the field at time t plus 1 is simply the state of the field at time t, mathematically rotated by the L39 operator. This discrete, step-by-step quantum walk across the nodes of the lattice literally is the unitary time evolution that reproduces the time-dependent Schrödinger equation.
But standard quantum mechanics relies on continuous, smooth calculus. Schrödinger's equation uses smooth wave functions. How do you get the smooth math of standard physics if the universe is fundamentally ticking like a digital clock moving from pixel to pixel?
The continuum limit emerges naturally through a concept in calculus called limits. Think of zooming out of a digital photograph on your computer screen.
Okay, I've got the picture open.
When you zoom all the way in, you see discrete, square pixels. The image is jagged. It's a grid.
Right.
But as you zoom out, as the mathematical distance between the pixels, which we'll call the lattice spacing A, is taken closer and closer to zero relative to your perspective, the discrete, blocky differences smoothly blend into a continuous gradient.
The pixels just disappear into a smooth picture.
Exactly. The continuum limit emerges naturally when the lattice spacing A is taken to zero. The authors of the SDMT make a profound philosophical assertion here.
What's that?
They argue that classical, non-relativistic quantum mechanics, with all its smooth, continuous wave functions, is nothing more than the long wavelength, unobserved limit of a bubbling, discrete hydrogen plenum.
Wow. So we basically invented continuous calculus to describe the universe simply because our instruments weren't precise enough to see the actual pixels.
That's the argument. We've been studying the ocean by looking at the smooth surface of the waves, completely ignoring the fact that it's made of discrete, individual water molecules beneath the surface.
And actually, if reality truly is pixelated at its base like that, that completely changes how we understand measurement, doesn't it?
It absolutely does.
I mean, if there's a smallest possible pixel, what happens when you try to measure something smaller than that pixel?
You can't. And that exact geometric limitation is how the SDMT framework demystifies the Heisenberg uncertainty principle.
Okay, let's lay the groundwork for Heisenberg for a second. In standard physics, the uncertainty principle says you cannot simultaneously know both the exact position and the exact momentum of a particle.
Right. The more precisely you try to pin down where a particle is, the fuzzier your knowledge of how fast it's moving becomes, and vice versa.
And in the standard model, this isn't due to having bad measuring equipment. It is treated as a fundamental magical fuzziness of nature. The universe just refuses to let you know both.
But the SDMT strips the magic away entirely. It shows that Heisenberg's uncertainty is a direct, unavoidable consequence of lattice discretization.
How so? Let's connect this back to the digital photograph analogy.
Okay, so if you're looking at a digital photograph, you cannot point to a feature that is smaller than a single pixel. The pixel is the absolute floor of spatial resolution.
Right, there is no subpixel information.
Exactly. In the SDMT lattice, your position uncertainty, which physicists call delta x, is simply proportional to A, the physical size of a single lattice cell.
So delta x is roughly equal to A.
Exactly. You literally cannot resolve position more accurately than the grid itself allows.
Okay, that covers position. The grid is only so fine. But what about momentum? Why does measuring momentum blur the position?
This requires understanding how momentum is mathematically derived from position. In physics, momentum is the Fourier dual of position.
Wait, Fourier dual, you just lost me. Let's translate that into plain English.
Okay, let's try.
Are you saying position and momentum are like two sides of the same coin, where looking closely at one side forces the other out of focus?
Essentially, yes. A Fourier transform is a mathematical operation that translates a signal in space, where something is, into a signal in frequency, how fast it's fluctuating.
Okay, space to frequency. Got it.
On a continuous, smooth surface, you can theoretically pinpoint both perfectly.
Yeah.
But on a compact, discrete lattice, a grid of pixels calculating frequency requires observing the particle jump from one distinct node to the next.
You have to watch it move across the blocks.
Exactly. And the inherent, jerky, discrete jumps of the grid create a mathematical limit to your precision when calculating that frequency. Your momentum uncertainty, delta p, becomes proportional to Planck's constant divided by the cell size, A.
Ah, so delta P is roughly h bar over A.
Yes. So when you multiply the uncertainty of position by the uncertainty of momentum, the cell size A physically cancels out of the equation.
Because you have an A on the top and an A on the bottom.
Exactly, leaving you with delta x times delta P is greater than or equal to Planck's constant.
That is so elegant. The inequality holds perfectly, but the philosophy completely changes. It isn't a mystical fuzziness anymore.
No, it's just the physical shadow of a discrete substrate. And Planck's constant itself, h bar, is no longer just a random number we pulled from a vacuum.
What is it then?
It is identified geometrically as the quantum of circulation in the superfluid. It is the exact physical measure of the action of a single jitterbug flip.
It's the literal gear click of the universe's engine. That makes so much sense. The grid dictates the uncertainty, but that still leaves the biggest elephant in the quantum room.
Oh, I know where you're going with this.
The grid might dictate the rules, but what happens when we as humans actually look at the grid? This brings us to the observer effect. The whole Schrodinger's cat is dead and alive until you open the box puzzle.
Wave function collapse.
Yes. In standard physics, the observer effect suggests that a particle exists as a smeared-out wave of probabilities, and the mere act of a human consciousness observing it somehow magically collapses that wave into a single physical point.
And it has led to endless philosophical debates because it borders on mysticism. Does the universe need us to exist? Does a tree falling in the woods make a sound if no one is there?
It's the most frustrating part of quantum mechanics. But these SDMT sources claim to completely demystify the observer, right?
They do, by framing observation not as a mental or conscious act, but as a purely physical fluid dynamic event.
Okay, break that down for me.
To understand this, we have to look back at the 1 Hertz jitterbug mechanism. Unobserved, left completely to its own devices, the plenum is a pure, frictionless wave.
Right, the superfluid.
Yes. It is governed entirely by the neutral Laplacian. In this undisturbed state, the temporal friction, that gamma constant, is exactly 0.
So without observation, the universe is a frictionless, perfectly unified wave, a silent, unbothered ocean.
It is in a state of pure unitary evolution. But what is an observation physically?
I mean, a photon has to bounce off the particle and hit your eye, or an electron has to interact with a detector.
Exactly. It requires physical interaction. In the SDMT framework, the human observer isn't magical. We are structurally located within the fluid at a specific fractal index. Specifically, K equals 37.
Wait, you said humans are at index 37. What does that actually mean mechanically? Are we just assigned a number?
It's a measure of our biological and structural fractal magnitude. Think of the scale. If the entirety of the macroscopic cosmos is at the top of the scale, and the smallest Planck scale pixel is at the bottom at K equals 39.
Human beings exist as highly complex, structured biological systems at the 37th order of magnitude down the chain.
Exactly. We are giant, lumbering structures relative to the quantum scale.
Okay, so we are a massive, heavy presence in the fluid compared to a tiny electron.
When a structure of our magnitude interacts with a quantum system to measure it, we aren't just passively looking at it. We physically inject a +1 Hertz pulse of topological pressure into the delicate quantum lattice.
A +1 Hertz injection. The authors of the SDMT call this paying the Greer tax, right?
Yes, the Greer tax.
It's like a toll booth.
Yeah.
You want information out of the quantum universe, you have to pay the toll by hitting it with a pulse of energy.
And this +1 Hertz injection does something critical to the fluid. It activates the thixotropic friction, gamma.
Oh.
Yes.
Uh-huh.
It shifts the Hamiltonian from that frictionless neutral state and forces it into either the Julia expansion state or the Mandelbrot contraction state.
Because it's thixotropic. When we look at it, we are essentially smacking the ketchup bottle.
Exactly. We are applying shear stress.
The stress of our observation, our heavy K, equals 37 interaction forces, the fluid to transition from a frictionless wave into a localized sticky state.
The injection of pressure breaks the unitary evolution. The fluid jams. It crystallizes into a definitive, observable state.
So the collapse of the wave function is literally just a geometric phase transition.
Exactly. It's the fluid literally freezing under the localized pressure of our measurement.
Think about what this means. There are no infinite parallel universes splitting off every time a quantum decision is made. There's no magical consciousness forcing reality to decide where a particle is.
It's just fluid mechanics. We apply pressure, the thixotropic fluid jams, and the wave condenses into a particle.
The sources actually cite a really fascinating piece of empirical evidence for this wave-fluid transition in the realm of biology. the cryptobiotic tardigrade.
Ah, the water bear. The microscopic, eight-legged, seemingly indestructible little creatures.
Right. When a tardigrade is exposed to extreme environments, like deep space, boiling water, extreme radiation, it enters a state called cryptobiosis.
It expels the water from its body, folds up, and suspends its metabolism completely.
It essentially pauses its life. The SDMT document suggests that the tardigrade isn't just protecting its cells, it is perfectly navigating this wave fluid boundary.
Yes. By shutting down its biological rhythms, it is suspending itself at the threshold of the topological boundary.
Essentially withdrawing its own +1 Hz jitterbug pulse to become more like the unobserved, frictionless wave. It ceases to interact as a heavy observer.
That is staggering if it's true. The implication is that biology is just macro quantum mechanics. The tardigrade survives by turning itself back into a wave.
But okay, to truly understand the deep mathematics of how this collapse actually happens, how the universe shifts gears from a frictionless wave to a jammed fluid without literally tearing its own spatial fabric, we have to look at the math backing this up.
Right, because you can't just assert this without rigorous math.
Exactly. And the sources lean heavily on something called motivic homotopy.
And this is where the SDMT framework attempts to bridge fundamental physics with some of the most abstract, high-level mathematics developed in the last few decades.
Motivic homotopy theory was formulated in the 1990s by a mathematician named Vladimir Voevodsky, right?
Yes, an achievement that actually earned him the Fields Medal. It was designed to unify two deeply separated fields of math, algebraic geometry and algebraic topology.
Which, to a layperson, usually have absolutely nothing to do with each other. Algebraic geometry deals with rigid, discrete shapes defined by polynomial equations. It's rigid.
And algebraic topology deals with squishy, continuous deformations. The classic example being how a coffee mug can be continuously mathematically deformed into a donut because they both just have one hole.
Right, so Voevodsky created a brilliant framework where rigid algebraic shapes could be flexibly deformed using a mathematical concept called the affine line, or A1, as the interval of continuous transformation.
The A1 homotopy.
I've always thought of the affine line in this context, like algebraic clay. The A1 homotopy is the continuous rotation, like the hands of the potter, seamlessly deforming a discrete algebraic shape into another shape without breaking it.
That analogy works beautifully, but let's extend it to see how the SDMT actually applies it. For decades, motivic homotopy was treated as pure abstract math. It didn't describe the physical world, it was just a tool for mathematicians to solve complex equations.
But the stunning claim of the SDMT framework is that the thixotropic hydrogen plenum is the physical, literal realization of this highly abstract math.
The universe is the math, rendered in hydrogen.
So how exactly does this abstract potter's wheel exist in the physical universe? What is the A1 homotopy physically doing?
It is the jitterbug. The continuous jitterbug deformation oscillating at that fundamental 1 Hz frequency is identified as the actual physical manifestation of the A1 homotopy.
Wait, really?
Yes. The abstract affine line is realized physically by the theta axis, which is the phase angle of the jitterbug rotation.
So as the jitterbug physically rotates the geometric orientation of the lattice from 0 to 90 degrees,
It acts as the spinning wheel in the hands of the potter. It continuously, seamlessly deforms the discrete lattice from the Juliet expansion phase to the Mandelbrot contraction phase.
the jitterbug is basically the clutch. It allows the universe to shift gears between states without stripping the transmission and tearing the Klein bottle.
That's a great way to put it. And the motif itself, the foundational piece of unformed clay being deformed by the potter, is the 39-cubed Golden Cross lattice.
The architects of the SDMT even identify the unique geometric interface between the unobserved wave phase and the observed fluid phase, right? A state of pure potential.
Yes, it's the helium-3 triple torus.
Helium-3. The sources focus so heavily on this specific isotope. Why is it so vital here?
Well, helium-3, when it is supercooled into its superfluid state, exhibits truly remarkable properties. In the context of SDMT, the helium-3 triple torus acts as the exact zero-energy kernel of the L39 neutral Laplacian.
There's one of those dense terms, again. Zero energy kernel. Are you saying it's a state of absolute zero stress?
Precisely. It is the absolute ground state of the Schrödinger Hamiltonian in this framework. It is a state of completely zero topological frustration.
Wow.
The math describes it using a term you might have seen in the documents, a mixed Tate motive of weight 91.
I definitely saw that term and immediately skipped over it. You cannot just drop mixed tape mode of weight 91 without explaining it. What does that actually mean?
Okay, let's break it down simply. A motive in Blavatsky's theory is like the fundamental DNA of a mathematical shape.
Okay, motive equals DNA.
Right. Tate refers to John Tate, a mathematician who classified specific types of highly symmetric pure motives. And weight 91 is a measure of its harmonic resonance within this specific geometric structure.
So saying helium-3 is a mixed tape motive of weight 91 means what physically?
It means that its geometric structure mathematically harmonizes perfectly with the 39 cubes lattice. It is perfectly symmetric. It generates no friction whatsoever. It is the perfect, unbothered anchor of the universe.
Okay, this is where I have to pause and ask the most fundamental question of this entire deep dive.
Go for it.
If helium-3 represents a state of perfect geometric symmetry, a state of zero tension and zero frustration, why does anything else exist? No, really. Why does anything else have mass? Where does the baseline energy of the universe, the gravity that is pulling us down to the floor right now, actually come from? If the universe wants to be a frictionless wave of unformed clay, why is it so heavy and solid?
This brings us to the final and perhaps most beautiful pillar of the SDMT framework. It explains mass not as a particle, but as an error.
An error.
Yes, it's called the mass gap and the Erdős-Strauss frustration.
The mass gap. For context for the listener, the Yang-Mills mass gap problem is one of the famous Millennium Prize problems in physics. There is a literal million-dollar bounty for anyone who can mathematically prove it.
Right, it's a huge deal.
The problem is basically, why do fundamental particles have a minimum irreducible mass instead of just being massless packets of energy zooming around at the speed of light?
Standard physics struggles deeply to explain the origin of mass. To make the standard model work, physicists had to introduce the Higgs field, which is essentially a mathematical band-aid with arbitrary coupling constants.
Right, particles interact with the Higgs field and gain mass.
But why they interact with specific strengths is completely unknown. It's just more free parameters.
But the SDMT takes a completely different route. It explains mass through pure number theory. Specifically, a Diophantine equation proposed by mathematicians Paul Erdős and Ernst Strauss in 1948.
The Erdős-Strauss conjecture.
The equation itself looks simple enough on paper. It's 4 over n equals 1 over x plus 1 over y plus 1 over z. But let's translate that abstract math into the actual fluid dynamics of the plenum. What do those variables represent?
In the plenum, this equation dictates how topological pressure is physically dissipated through the lattice. Imagine a localized pulse of energy, a perturbation, hits a specific node in the Golden Cross.
Okay, a wave hitting a rock.
The term 4 over n represents the total incident pressure arriving at a given fractal stratum, where n is the index of that stratum.
So a wave of energy crashes against a rock. The 4 over n is the raw force of that wave.
Exactly. Now, to survive the crash without the Klein bottle membrane mathematically tearing, which, by the way, would create a singularity, a black hole, the lattice has to divide and dissipate that incoming pressure along its 3 spatial dimensions.
Ah, the 3 axes.
That's the 1 over x plus 1 over y plus 1 over z part of the equation. The universe is desperately trying to find integer fractions, clean whole numbers, to cleanly route the energy away through the x, y, and z axis.
And for most layers of the fractal, from n equals 1 all the way up to n equals 38, it finds a way. The math works out. The pressure dissipates cleanly.
It does. But the positive mass gap, the irreducible weight of reality, is mathematically guaranteed by what happens at the very bottom of the fractal, at the maximal index n equals 39.
The paper referred to this as the autopsy of the n equals 39 singularity, which sounds incredibly dramatic. What exactly goes wrong at 39?
At scale 39, the fluid tries to dissipate the pressure evenly across its 3 axes. It desperately wants an isotropic solution, a perfectly balanced distribution, but it literally cannot do the math.
Wait, what do you mean it can't do the math?
The integer 39 is incompatible. It doesn't allow for a perfectly balanced alignment with the geometric constants of the lattice, specifically the golden ratio propeller, beta. The arithmetic simply fails to provide a perfectly symmetrical escape route for the energy.
This is the critical mechanism, isn't it? This mathematical error, this fundamental arithmetic incompatibility between the number 39 and the geometry of a 3D grid is the actual physical cause of mass.
Because it cannot find a symmetric solution, the system is forced into a state of permanent topological frustration. It has to settle for the least bad asymmetric integer triplet it can find to route the pressure.
And what is that triplet?
For n equals 39, that triplet is x equals 26, y equals 26, z equals 39.
Let's visualize what that actually means. Two spatial axes take a certain amount of pressure, mathematically represented by 26, and the third axis takes a completely different, disproportionate amount of pressure, represented by 39.
Right, the pressure is inherently unbalanced.
And an unbalanced pressure creates a permanent warp in the spatial gradient. Because the grid can't resolve the pressure evenly, it is forced to constantly adjust. It's forced to vibrate.
It vibrates at an irreducible 1 Hz frequency to continuously process that residual stress and keep the membrane from cracking.
That 1 Hz beat, that's the mass gap. That is the physical mechanism of weight.
It is the fundamental heartbeat of the universe, born directly from an arithmetic error. Gravity, mass, and inertia all exist simply because the integer 39 refuses to divide easily into the geometric constraints of a fractal Klein bottle.
That is mind-blowing.
The mass of a fundamental particle is simply the measure of the thixotropic drag generated when that particle encounters this fundamental, vibrating 1 Hz frustration.
That reframes the entire concept of existence. The universe exists. We exist as massive physical beings anchored to a planet because of a fundamental mathematical incompatibility.
Yes.
If 39 could divide perfectly, the energy would dissipate instantly and evenly. Perfection would mean a silent, empty, massless wave.
A universe of pure light, but no matter. It is the frustration, the mathematical imperfection at the base of reality that creates matter. Gravity is just the topological viscosity of a fractal liquid crystal forced to its elasticity limit. The universe is heavy because it is geometrically frustrated.
Okay, let's try to pull all these massive conceptual threads together because we've covered a staggering amount of ground.
Synthesizing what we've covered, the SDMT framework presents a universe that is a discrete, thixotropic superfluid hydrogen lattice, the Golden Cross, made of exactly 39 cubed nodes.
And this fluid lattice generates the Schrödinger equation natively. It's not a magical rule, it is literally just the discrete Laplacian L39 stiffness matrix of the fluid. The eigenvalues of that matrix give us the exact masses of the particles, tuning them like acoustic notes on a piano.
Right. And its unitary time evolution naturally reproduces both the time-independent and time-dependent Schrödinger equations.
And it gives rise to Heisenberg's uncertainty principle not through quantum mysticism, but simply through the physical pixelation of its cell size. You can't measure smaller than a single pixel. Delta X is roughly A, and delta P is proportional to h bar over A.
It explains wave function collapse as a deterministic pressure-induced fluid jam caused by the 1 Hz jitterbug injection of the observer. We smack the ketchup bottle, and the wave turns into a particle.
And finally, it generates the mass gap through pure mathematical frustration at the n equals 39 level, forcing a perpetual 1 Hz heartbeat to keep the universe from tearing.
And it does all of this with 0 free parameters. Everything is derived from the integer 39, the scale propeller beta, the temporal friction gamma, and the shear angle phi sub c.
This raises an important point for you, the listener. We've been talking about quantum mechanics and fluid dynamics, which can feel incredibly distant and theoretical.
But it's not distant at all.
Right. Because this lattice is fractal and scale invariant, it means that biology and you yourself are just a macroscopic fractal echo of this exact same 1 Hz geometric cycle.
The scale changes, but the mechanical principle is absolute. The hydrogenase enzyme in your body, which processes protons to give you energy, operates on the exact same thixotropic phase inversion as a geological nuclear reactor in the Earth's crust, or a star in deep space.
It is just shifted by the scale propeller, beta. You are built of the exact same math as the quantum vacuum. You are a standing wave of topological frustration, stabilizing the fluid at your specific scale.
It's a beautiful way to look at life.
And that leads me to a final, slightly provocative thought I want to leave you with to mull over on your own. We established that the human observer structurally sits at the fractal stratum k equals 37 and maybe extends to k equals 39 in our ultimate biological complexity.
Right.
And it is the human observer's heavy interaction that injects that +1 Hertz pulse, paying the Greer tax, activating the friction gamma, and collapsing the wave into physical, measurable reality.
We literally provide the necessary shear stress to crystallize the wave.
Does that mean the universe engineered us specifically as the necessary mechanism to observe and stabilize its own geometry?
Oh, that's a deep question.
Think about it. If unobserved, it's just a frictionless, infinite, massless wave of potential. It needs the +1 Hz jitterbug pulse to collapse into a classical thixotropic fluid. Are you not just a person living in a random universe, but the literal structural lens the universe uses to force itself into physical existence?
It implies that consciousness and observation aren't just accidents of evolution, they are the functional valves the fluid uses to actualize its own mathematical form.
Something to think about the next time you look at a simple glass of water and realize it might just be vibrating with the exact same 55.17-degree geometric angle that holds the entire universe together. Thank you for joining us on this deep dive into the SDMT framework. We'll see you next time.